what we're going to do is examine this question, what do machines think? So right off the bat, it's a slightly provocative title. The most provocative title I ever came up with was for a school in the East End where nobody ever turned up for an evening lecture, and these were all adolescents, and I bet the headmaster I could fill the hall, and he said, okay, a pint on it, and I got the pint, and the title was, what's sex got to do with IT? The parents came, the grandparents came, all the kids came, all the teachers were there, the whole deal. You know, all adolescents think about is sex, and that was it. So, and what the topic really was about artificial intelligence, artificial life, and the use of genetics in terms of creating intelligence and changing the way we do programming. So there's a bit of that in here this evening. So possible subtitles: when machines build machines, surpass us, take over, or come to our rescue. People get very nervous about this topic. They get very nervous about machinery. Several reasons. One, it's always horror stories in the press, and it's always horror stories coming out of Hollywood, and we only ever see the downside. So I want to deal with both. So I'm going to put the conclusion up first, because if I don't, I might not get to it if you ask lots of questions. So what we're going to do is have a look at some unusual stuff, and understanding nonlinear systems presents us with our biggest and most important challenge and opportunity. Whatever advance and advantage we've enjoyed through linear models, thinking and endeavors, will totally be eclipsed by the move into the realm of nonlinearity. We have no mathematics and no generalized solutions for nonlinear problems. We're spoiled rotten at school and university by being fed a series of problems that have solutions. University professors and teachers love that because they can market. You get straight out of university into the real world, and you find that there are massive problems. The flow of fluid, air, through a jet engine isn't nice and laminar, as taught in class. It's turbulent and chaotic. The flow of air over an aerofoil is chaotic. Weather systems are a good example. Nonlinear, chaotic. Management systems, companies, financial systems, everything. But we have no mathematics to deal with it. The only thing we can do is model. So it presents us with a challenge, and it's kind of fun to look at. Because we didn't know Newton's laws of motion, it didn't stop us creating the bow and arrow and the spear and becoming pretty damn good hunters. So in many of the topics I'm going to probe this evening, we are throwing rocks and inventing spears and bows and arrows. We don't have a theory, but it doesn't stop us being reasonable at it and gaining knowledge.